All right, it looks like we're going to go ahead and get going here. Want to welcome everybody. We might have some stragglers that come in, but I want to welcome everybody to the Working with SolidWorks Assemblies in a PDM Vault. I'll be one of the people talking on the presentation today. I'm Ryan Cole. I'm an application engineer with GoEngineer. Also online, we have John Mcarthur. Would you like to introduce yourself, John?
Yes. Good afternoon.
There you go. Man of many words. We're going to go ahead and start this up here. And basically, what we really want to get with you guys about is, when working with assemblies, whether they're large or small, if you're working in groups or alone, if you're working on a network or not, some of the common issues that we do run into. And I had John come in because some of the issues that I've been running into working on my own computer, I'm starting to kind of wonder if PDM isn't a way to go to kind of help me out. So we kind of want to demonstrate how PDM can help in a lot of different systems. So we're going to kind of discuss a couple things. We've got some topics that we're going to cover. We've got the working locally versus over a network, some of the ideas and what's going on there. Multi-user environments. Not all of us work in I mean, a lot of us are probably working by ourselves with the COVID thing going on, but, we're going to be getting back into those multi-user environments. And also, we don't design and engineer things the first time most of the time. We usually have versions and revisions. And then, finally we get to really just managing those files and how they're out there and some of the headaches we may have and what PDM might be able to do to help us get through there. So, go ahead and let John come in. Come on in, John.
So yeah, we're going to talk a bit today on the differences in working with SolidWorks files within the PDM environment. And Ryan and I were really kind of targeting this towards a lot of customers that may not already have SolidWorks PDM. I hope by the end of it, I've shown enough information for anybody with PDM to have gained a little bit of knowledge here as well. But like Ryan mentioned, he's going to be kind of taking the role of a user off on the network drive and some of the issues that they've been running into. And then I'll kind of be speaking to what PDM brings to the table there with respect to those working environments.
So, getting into it, without a PDM system, there's a lot of things that we kind of get into. One of the things that I notice, especially on a network, especially with larger companies, especially with more people, larger groups and stuff like that, is really like a performance degradation. It takes a long time to save, it takes a long time to open, and I'm always scratching my head on like, is it my computer having issues? Is it a network issue? If I've dealt with customers that have had this issue, really sometimes it comes down to is, are you starting to see certain times like right before lunch when everybody's saving everything? There's more network traffic going on, stuff like that. Everybody's getting ready to leave, so they're saving stuff or whatever during before lunch, after work, or whatever. But along with that, we come into some file corruption issues, and at least from a customer standpoint, these can be frustrating. And as a support person, we've also found out a lot when we are seeing a lot of file corruptions. One of the first questions I usually have is, are you saving this onto a network? And I will say 95% of the time, the answer is, yeah, we're saving it on the network. Those are things that we run into like that. But the other thing we get into is really organization. And if you've used SolidWorks for say more than like a week, naming files, renaming files, moving files to a different location, at the beginning of a project, sometimes we don't know what the part numbers are going to be. It's called bracket 1 or bracket 2 or something like that. And then afterwards, like, oh man, like you've got this massive area where you get into it and all these files are in line, and it's just this big mess to get into. And it's sometimes we want to organize it. Like, I want to put parts here and I want to put customer parts here. Don't get me going on standardized parts, but that's really the thing there is this organization, and sometimes we can't do it ahead of time. We have to deal with the headache of renaming and moving and lost references. SolidWorks constantly screaming about it. And then one of the other things is like IT, like if we get done with something and I want to kind of protect it, I've got to get my IT professionals involved. And sometimes that's good, sometimes it's bad. We can tell them to, hey, lock this folder out and only let one person in. But it's like you got to get that third party involved. And sometimes it's just not great. So as far as that's concerned, what is PDM like? Can PDM help the stuff out, whether it's performance, it's organization, it's the read write access?
Absolutely. So one of the first things, to speak to there would be the PDM performance side of things. When you're working over a network, you're at the mercy of the pipe, the hard drives going back and forth to that server, the number of users and the I/O on that server, where PDM's designed to automatically locally cache the files, right? So as you bring the latest copy down to your local drive, you're actually saving and loading from that local directory. It's still reading back to a database to, gain information, but you're only pushing the changes back across the network when you say check in. And the user controls how often they're actually checking in that file compared to working on the network. Every single save, every open is happening over that pipe up to the network, RAID control and such.
It is, and
Um,
is everything getting pushed over?
no, only the changed files are actually pushed. So if you check out an assembly with hundreds of parts in it and you modify 3 or 4 of them, you're going to be checking back in the assembly, the sub-assembly, and the 3 or 4 modified parts. So you're actually reducing the traffic there as well.
Okay, so that could, I mean, that's going to alleviate a lot, especially if you got quite a few CAD people working in the PDM system. That could be a significant increase in your efficiency on your network.
Absolutely. File corruptions, down to a minimum at that point because you're working, local off of the C drive. Generally speaking, with today's technology, that's a solid state drive as well. So you're getting faster save ops in a lot of cases as well. And then the file corruption is largely happening when a file truncates over the network. So we eliminate most of that. In the rare occasion that it does still happen, and we'll speak a little bit further about this on another slide, is we have versions of files, right? So instead of having to go to IT to go get a backup copy or something, if you have a corrupt file, you can just go to the prior version and then move forward with your day. On the folder structure side of things, you can set it up so that your PDM vault has whatever folders you want and let engineering or anyone make that folder structure on demand. But many companies choose to do it at a template level. So they have a very structured and uniform project folder structure that spits out the same subfolder structure every time a new job is created. And you can even put in specific, job starting files within that environment with the PDM template.
So it almost
And
gives you like a, it almost gives you like a project startup at that time.
it does, yep. Then the local PDM admin has a PDM administration utility is installed on every client, and then password protected, admin rights will allow read-write control access. So typically speaking, during an implementation, we train a few PDM administrators at a company, and then they have rights to control the read-write access of folders and workflow permissions within PDM, so that the only thing IT needs to be involved in is backing up the server and updates once a year.
Okay, so we don't need that third party. It sounds like the admin is usually a member of engineering in most cases. Would you say?
Generally speaking, yes.
Okay, so I mean, definitely, it looks like there could be some. It could ease up a lot of things, especially if you're dealing with larger assemblies or opening large files. This is because you're local, it's going to be working faster. So, all right, well, that sounds pretty cool. So that's something I could definitely keep in mind. Um, well, multi-user environments. I mean, this is another thing. I mean, there is a problem with working with multi-users on a network, but inside of SolidWorks, it becomes a little bit difficult. I know, like prior experience, I worked at one place where one of the coworkers would come in early. He would open one of the assemblies so he could grab everything, and then he would minimize that SolidWorks and start up a brand new SolidWorks. So he always had two SolidWorks running throughout the day. It was crazy. And anytime we ran into one of those parts, because he opened the assembly, he basically took read-write control of all the files inside of it. Well, we had to go kind of ask him, quote unquote, beg him to allow us access to those files and stuff like that. So, one of the tricks that we've learned, especially out there, is, like there was times where someone would say, "Hey, I need to get into this," and if it was a major part of the assembly I was working in, I'd have to save everything, close it down, have them open up the subassembly that they needed to get into, and then I could reopen it, and then I would only take control of stuff that he hadn't already had control, but we still had this like juggle thing we were going on. We did learn some tricks though. You could suppress a subassembly, you could suppress a component, save the assembly. They could open it because since it's suppressed, it's not loaded in memory. We're not, grabbing it or anything. Then somebody else could grab it. But once again, there was like this big halt. There was a save, and honestly, John, I mean, some of my save times back in the day were like 20 minutes long. So this wasn't like something quick and easy and dirty to do, regardless. The last one we had was the reload capability, being able to right click on a part and say reload. There was a little checkbox that said reload it, read only, and then that would release it as well too. That one was a little bit quicker because that was pretty instantaneous. But if you're working on this massive or assembly with subassembly and subassembly and subassembly and parts, and you're trying to go through that, sometimes it was easier just to save it all, close it down, let them open what they needed, and get back into it. How does does the PDM help with this multi-user environment as far as being able to juggle these parts around, especially with multiple people working on it?
Yeah, absolutely. If I had to say one thing that was PDM was really designed for, it was multi-user environment, right? So Windows in and of itself, the problems that you just described come from an inherent nature of Windows, which is that once the file's open in RAM, it's in use by Windows, and therefore, it's going to be read-only to everybody else. PDM handles that entirely differently, right? There's a database in the back end that has a lock and unlock feature called checkout and check in, right? So if you go to any given assembly, you can open that assembly and choose not to check out anything, and it leaves write access on the server for somebody else to work on. Likewise, they can open an assembly and get rights to that while you have it open. And all that's going to happen is it stops you from checking out that top level assembly.
So, well, but if I have something like if I've got the main assembly checked out and then a user checks out something underneath it, like does everything just automatically update on the screen for me? How do I get things to update so I can see what changes have occurred out there?
Sure. So live inside the PDM add-in interface, it will show you who checked out the files in those subdirectory or in those substructures underneath of that. And then as they check in changes, it will flag them in a red color and show you that you have an older copy of the file. Then live inside of the SolidWorks interface, all you have to do is right-click and get latest version, and it will pull those changes across the network to your live assembly. So you can get true simultaneous work.
Okay, so you're actually getting feedback of, I mean, because it used to be like, well, tell me when you're done with this so I can, reload the file or whatever. But you're getting feedback through the PDM admin right inside of the SolidWorks environment.
That's correct.
Awesome. Okay. All right. So that would definitely relieve that up. It would stop the yelling, at least in the department, as we're trying to figure out who's got what and stuff like that. All right. Well, cool. The other thing that we get into versions and revisions, where do I put my data? Like one of the big things that, I've seen out there, one of the things that I've cried when I've gone to companies and had to start working there was renaming parts. I mean, we talked about that earlier as far as the renaming of a part and stuff like that. And it's like, okay, well, we made a change, so now we're going to call this dash rev B, and then we make another change to that and we call that rev dash C. And then I got to go through all the assemblies and all the subs and make sure that they're all looking at the new version, and then someone comes in and is like, well, what did that old version look at? Well, oh, that's okay. Well, we took those files and sometimes we're zipping like whole projects up and saying, this is rev B. Sometimes we're moving these to a different archive location just so they don't accidentally get loaded in. And, the other things that we run into is like, if someone doesn't follow the rules, like there's all these intricate rules and little dance we got to go through with renaming and moving and stuff like that. Well, if someone doesn't do it right, well, what do you know? How do you know if you're looking at the right one? So then you sit there and spend a half hour looking through everything, going, "Yeah, I think this is right." And then last but not least, it's like releasing files. Um, you know. I've worked with my IT crew. They've got a release folder that's written. It's make it so it's read write protected. There's one person in a department that can move the files in there, but once again, it's a move file, and everything's getting shoved in there, and then it's like it doesn't work, and I don't know. It's always a big headache. So once again, it's like, is there anything that PDM can do with this particular, these particular things that we run into?
Sure, yeah. The archiving of data, like I mentioned earlier, is kind of an automated feature of PDM. As you check in any change file, it's going to version that file, which is a little different than a revision, right? A version is going to be a checked-in change and is a unlimited counter within the system, and it stores every copy of that out on the server. And then a revision is going to happen when a file moves through a workflow. So one of the things that you mentioned there with releasing a file on the network is actually moving that data. PDM kind of solves that in a couple of different ways, right? One, if you move files within PDM, you can, you don't have to worry about breaking references, but probably more importantly, you don't actually need to move files to release data within a PDM environment. So one of the things you can kind of see in the slide here is a pretty simple design, review, release workflow. And that release process there where it says ECR completed, that's going to be just a workflow transition that happens in the database and triggers other things to occur, like saving off a PDF, notifying individuals, and then the workflow rights can be set so the manufacturing could see that file on the shop floor now, and a notification could be sent to the manufacturing group to be able to get to that data.
So the PDFs that I have to save out all the time, the emails I have to send out to the other departments, that's something that the PDM can handle through this workflow?
Absolutely. It can be set to do database notifications or full-on email notifications with hyperlinks to the files. Workflows are completely customizable as well, right? The simple one that we have on the screenshot here is just what I call a three-state workflow. I've got customers with hundreds of states. We can go through multiple workflows and link them together. So you can really match and mirror up to your processes. And it really acts as a good stage gate for searching capabilities as well. So you can see what files are in review, what's in design, and what's been released before.
So it's not making a copy of the files, it's overwriting the files in place. It's managing all this in the background.
Yeah, it's a little bit of both, right? So the end user sees one file, right? You don't have to have copies out on the network and the newest version, right? But it is actually taking a full-on copy of that file on the back end of the server. And then when you go to get prior versions, it can cache those locally, but it looks like one file to the end user in the Windows Explorer interface. So there's a couple of other commands, worth mentioning there too. There's some commands called move tree and copy tree. And move tree is really designed for moving data around within a vault, but you can actually take a file and all of its references, similar to pack and go, but just not actually make a copy. It takes those files, moves them within the vault structure, and reorders those files, and then updates the database where they move to so that no references get broken. The copy tree command is very similar to pack and go in that it will make similar but different jobs, and that will let you also create independent projects within a new folder structure as well.
All right. Well, um, here's the deal. I mean, when you're moving the stuff around, when you're changing things, when you're changing names, sounds like with the PDM, I don't need to change names so much, but there is an organization level that we might get into. It's once again, I don't know where parts are going to lie. I might have parts in one area, another area might have a working directory. So, when we rename the files, the references are broken. It's easy enough to connect that together, but when you're talking about hundreds of components in an assembly, that could get ugly. Moving the files around, once again, we can do it. There's tools in SOLIDWORKS to help you do it too, but sometimes it's easier just to move it and let SOLIDWORKS ask where they're at. But definitely duplicate files. We have thousands of these, whether they're standardized parts or whether they're another part being used over and over and over again. Those are always causing issues for us. And really, I mean, trying to find those duplicate parts too. I mean, if I've got 30 of the same part scattered all throughout my network, how do I know where they're at? Where do I know where that's going on? How do I know if they've all been updated? And I'll guarantee it, nobody's updating them all. And then getting into the standard parts, how can we leverage something like that? And then, when we have a project that's pretty similar, like we'd like to fall back on the pack and go, and that seems to work pretty good. But I don't know. It seems like there could be something better out there. So, once again, same question going back. How does this look with PDM?
Right out of the gate, the rename and move doesn't break references and it tracks all those changes. So without PDM, there is a SolidWorks rename function, generally in your right-click menu, and that's actually using Windows Explorer or SolidWorks Explorer DLLs to track those changes. The downside of that is that it's got to go actually open with API in the back end all of those files and update the file headers. So a rename or a move through that on a large data set or a widely used part can be very time consuming.
Oh, it's extremely time consuming.
So PDM handles that in a very, very different way. It doesn't actually modify the header of the SolidWorks files. PDM goes into a database and says, hey, this file was called this, it's called that, it was here, it's moved here. And that table that it updates basically takes precedence over the file header in SolidWorks. So before you open that SolidWorks assembly, it's actually still got the wrong headers in it. But when you open it from a PDM environment, it looks at that table and says those files moved over here and they're called this now. So when it opens, it resolves all of the correct references. Then on the next save and check-in, you are updating the file header and they match again. But there's actually a time period where they're out of sync.
So this sounds like, well, it sounds like it's faster. I mean, if you're telling me a database is controlling this has got to be way faster than like a search and find through Windows search.
Yeah, absolutely. And that database is also leveraged when you get into the blocking of the duplicate files, right? So it's optional within a PDM environment, and the options effectively are block all duplicates or block duplicates of specific file types. So if you want, for example, in the graphic here and in the PowerPoint, if you want to block parts, assemblies, drawings, we can do that, but allow for, Word docs and design tables to have the same names, right? Or you can block absolutely everything so that you need 100% unique parts.
Okay.
It's important to note that it doesn't actually block copying them into the vault, because that would be very difficult if you were just copying and pasting to make a new bracket, right?
Right.
But what it does is it warns you that there's a duplicate name somewhere else in the vault, and then it blocks the check-in operation so that you can't put two files to the server with the same name. You need to give it a unique part number, and there's actually serial number functions within PDM to help you get unique numbers on your files as
Okay.
well.
All right. Well, that sounds good.
So standard parts, there's a lot of ways to handle standard parts, right? I've talked to hundreds and hundreds of companies across the country on standard parts, and everybody kind of handles them a little different. I've seen some companies that have been fairly successful copying all their standard parts into every job, and that happens with that pack and go very commonly, right? And the major downside of that is you don't have a true where used, right? If you've got 30 cylinder files all over your network and you're referencing the same cylinder once in 30 different assemblies, if you look at the where used anywhere within that, it's used once in this assembly, right?
Yeah.
So, one of the questions I always ask those companies are, well, if that cylinder gets depreciated and you now have to replace it with a different cylinder that has a slightly different bolt pattern or something, how do you know how many assemblies you're really impacting?
Well, I mean,
Right?
I would go to my old green screen system that's 30 years out of date, have a printout and get a highlighter and start finding stuff. So, because that's usually pretty accurate, right?
Sure. So PDM will actually, track all that where used reference if you handle standard parts as their own folder structure, right? So we'll jump out and take a look at that here in just a minute. And then lastly, I mentioned in the prior, the copy tree, being able to make your similar but different jobs, as opposed to pack and go. They have a lot of the same features, but one of the major benefits of copy tree over, say, a pack and go is that it knows all these vaulted references and it knows metadata information and locations about those files beyond the file header of SolidWorks, right? So when it does its copy operations, there's just much more that you can do with it. You can, rewrite new file names, you can serialize part numbers, you can grab all the drawing references. And I find, in a perfect network environment, Pack and Go does a lot of that well. But in many cases, when you have data scattered on lots of different network drives, even your Pack and Go doesn't contain all the files when it's done because it just couldn't find some of those references. They got named or moved, and SolidWorks the files weren't updated. So now, Pack and Go is limited by what it can find in the file header and simply is missing references when it's done. Where a
Okay.
copy tree finds all that from the database and very cleanly, kicks out that similar but different job with all the correct references.
Okay. All right. Well, I mean, so we've been talking about a lot. I mean, can you kind of show me some of the stuff we've been talking about?
Yeah, sure, absolutely. So here's a local PDM vault view with folder structure in it, and this is totally customizable. This particular vault has projects, and these are serialized in this case. And I used the project template that I mentioned earlier to be able to generate most of these. But I've also created a subfolder structure within this, right? So I've got CAD and documentation, et cetera, in there. And then I've got a specifically named one here called LAP, is Large Assembly Performance. And this CAD directory is where I'm actually storing the main assembly model as well as all of its job-specific components, right? And this is where it's going to show you the versions of the files. I put these in this morning, so they're on version 1 in this case. And the main assembly is sitting at version 1 at this point as well. Now, if I'm looking to add some metadata to that, right, I can just right-click and check out. I can go add a description to this file, and PDM's data card capabilities can actually push this information into the files. So you can actually update title blocks and metadata information by simply updating this data card and then checking the file back in. Adding comments here is going to allow you to see this in the history of the file. So just a quick blurb can go a long way in showcasing that new version functionality. And here you can see it's got no revision yet, but I'm at version 2 of 2. And the revision is going to happen as I move it through the workflow. Currently it's at production design. And if I want to move that downstream, I'm going to just right click and change state. And it's going to move through that 3-state workflow we saw earlier. Now optionally, all the job specific files can come along for the ride, or all of the files depending on how you set up your vault. And that will move those files through the workflow. And that moved roughly 1,600 files to review that fast. Right? I can bounce those as changes needed or go on to a completed state where these files will get released. Now here, this takes a bit longer as it's chugging through roughly 130 files that it's pushing through. Now it's 1,600 or so, top-level assembly references, but of that, we're at about 130 or so unique parts, right? And the reason it takes a bit longer as you're releasing in this case is because I'm actually triggering a number of things to occur here, right? We are writing metadata on these files. We are stamping the revision on these files. We can write in, checked by, revised by, and then you can even trigger a workflow transition to generate a PDF file for you as well. But you can see there that it stamps A on all of the files, both in PDM with the counter and on the data card that writes to the title block. And you can even tie that out to the rev counter as well. PDM's got tons of bill of material functionality, and we didn't talk a ton about that in our conversation. But this is a quick example of a bill of material just showing file name, config, part number on all this stuff. And you can customize these tabs to anything that you'd like. One of the added benefits here with PDM is you can actually get to prior versions of an assembly. So if you've got a Rev A and a Rev B and you're wondering what the differences are, you can actually run a compare and it will color code the differences in a bill of materials between versions of the same assembly. Okay. I can then look at the history on this document, and it shows everything time-stamped, that this file's been through, shows every check-in, when I added the description, when I sent it on to Rev, and you can get back to these prior versions here. That's one of a couple of ways that you can get to a prior version within PDM, but that'll actually let you locally cache an older copy of the file. The Contains tab is very similar, but this is showing the actual file header of SolidWorks, and here we can see all the top-level assembly references and all of those standardized parts underneath. So these are showing some extrusion profiles and some standard components. You can see here this one has like 328 of these referenced within the assembly. And you can see over to the side I've got those going to a standard parts directory within the vault, right? Without even knowing where they are, though, I can just right-click and browse to in a new window, and that will showcase where they are stored within the vault. And you can set up your standard parts directories however you'd like, but it builds out that where used that I was talking about earlier here. So you see multiple assemblies and sub-assemblies that particular part is referenced in upstream. So I can really get that one point of reference and still have all of good references downstream, which allows for better updates and depreciation of files. So jumping over now, I'm going to fire up a new project. And my particular vault set up to prompt me as well as burn a serial number, so I can do either. I'm just going to call this one LAP2. Okay, I'm just copying that original LAP assembly at this point. Throw in a project name. And then I also have a project manager drop list here. This is for a fairly new functionality where you can do notifications based on who's the project manager, as an example. Do a quick refresh on the folder, and there's my new folder and subfolder structure. So I get a very repeated folder structure. And then this CAD directory is where I'm going to be putting the similar but different job from that copy tree operation. So I'll jump back to the main assembly here, and I'll just select that top main assembly. You could also go off of its drawing as well if you prefer. And then you just go to Tools, Copy Tree. And that's going to bring up this dialog box. The first thing that I always do is click the Browse button over to the right, and then I'm going to give it that new location that I just created so that all the new job-specific data lands there. Now this particular vault shows a duplicate file blocking going on for these top-level assemblies, right? And it has a job-specific kind of code at the front of it of ADA. So I'm going to use this Replace button here and just do a Replace All ADAs, and we'll do an AADA here, and then select OK. And that's going to swap out all references where it found an ADA and highlight those in yellow. So if I scroll over to the right, we can see it's automatically renamed all of those files downstream. Now, not every file within this assembly had those job-specific things, right? I've got aluminum extrusion profiles, I've got, standard parts, and you can see here that there's an administrator excluded from this copy. So one of the options in PDM is you can actually block copy tree from making copies of standard parts, which is really good. Non-standard parts are getting renamed, and you can choose to copy or reference those. And then down at the bottom here, I've got some duplicate file present stuff. And this is still the case because they didn't have ADA in the name, right? So there's a few ways that you can handle these, right? I could select them all, and I could say, add a suffix or a prefix to them. In this case, I'm just going through and showing that you can manually rename these files as well. So you just simply click on there, and you can rename it to anything that you would like. And this can be a complete rename. This can be an appendix. This can be a suffix on a file. Effectively, you have total control over the target file name. In fact, there's even an ability up above there that says rename with serial number. So if you have a serial number system set up in your PDM vault, you can just select the file and say, grab the next serial number in line as well. So there's just tons of different options for that file management and file reference control here. As I look, I've got pretty good list going here now. If I go into some of the other subs, I see there's a couple more duplicates around. I'm going to get one more here and just do a manual rename. And there's a few more I'm actually just going to leave here, and I want to show how to handle those later if you miss them during the copy operation. So the copy button's now live, as that I can make that copy tree operation. Optionally, you can check in on copy. If your plan is to work on this new job, though, you probably want to leave that off. And then you can choose to include drawings, relative paths, and or renumber serial numbers on data cards. So when you hit the copy button, it's taking a copy of all the local data that was the ADA assembly in this case, right? And it's going to chug through that as it pulls 130 plus files into kind of a temporary clipboard, if you will, and then it pastes them with all of the mass renamed files. So you see the AADA files now pushing through. And at the tail end of that, it's going to pop up and say, hey, here's the two duplicate file names that were still present. So there's this barrel file, and then I've got this 4.2 GUF file that's still in a duplicate name within the vault, right? So I close on that. And I'm going to go look at that new assembly over here in LAP2 in the CAD directory. And here's all that job-specific data that it copied with the newly named references. Now, I do have a few duplicates here that it stated and showed me where they were. But one of the things I found to be the easiest is I just check in the main assembly. And it's going to bring up a reference dialog box here. And then here you can kind of see what it's done, right? There's any file that's got a check next to it is going to be something that is new, checking in for the first time. Anything that's grayed out is going to be a file that wasn't part of the copy, but is still referenced by the assembly, right? And then I've got a few of these file name not unique scenarios going on here, which it already flagged to me and told me that it was going to happen, right? But what I found is if you just check that in anyways, it's going to push all that data in, and it does not block the main assembly and all those other parts from checking in. It simply blocks the two files that were duplicates, right? So now I have this barrel and this assembly that needs a new name. So in this case, I'll just manually rename that to barrel 2 because I missed that the first time, and then just check that file in. And now that 4.2 GUF file is going to have another rename as well. Here we can see that it's tracking the reference of what the file was renamed from and to. And now that assembly file itself is going to have those new references based off the database. So I'm going to clean up that 4.2 assembly here as well. And if I take a look at the preview here, it's pretty obvious this was supposed to be a job-specific assembly, a conveyor belt, and we're going to build those custom. So here I'm just going to give that the prefix of the AADA with a dash to match up to the rest of the nomenclature below. And then I'll go ahead and check that in. And now the last step will just be to check out and check in the main top level assembly here. You can see that it's showing that it's been modified. That's the green up clock. And if I just simply check that out by taking ownership, and then all I need to do is check it back in, and that will rebuild all the references below it. So this check-in operation didn't physically change any CAD models, but that rebuilt the file header so that if I now go and look at the bill of materials or the contains tab, it's going to rebuild and find all of those sub-assemblies accordingly. And I now have all the downstream references for standard parts in their respective folders. I've got all the downstream references for the job-specific parts, all renamed to the AADA, and that can be any, custom field that you want. Some people do job number, some do a code. A lot of different ways to handle that. And now from here, I'm going to go ahead and open that up in SolidWorks. And we'll take a look at what happens during the open command, right? One of the things that Ryan mentioned earlier was that, sometimes we just break references and it's faster for SolidWorks to open up, not find them, and then I'll browse and go look for them on the network, right? Well, here it's popping up with a checkout dialog, and I hit the cancel button. That doesn't cancel the open, and I do find a lot of understanding about that, right? If you cancel the checkout dialog, it's still opening in SolidWorks. You're just canceling checking out. So this is opening that read-only copy that we talked about earlier, right? We see a lot of reference points here that are going to clean up as it opens in large assembly mode, which is something Ryan's talked about in other presentations. And then I've got a lightweight assembly going on here as well. But importantly, it didn't prompt me for any missing files. If I go take a look at that barrel that I manually renamed, it's got the -2 on it, right? And all of the sub-assemblies downstream are updated relative to those standardized and reusable parts, right? So we've got some 1,600 component assembly here on the screen, which isn't massive, but a pretty decent sized assembly. And we're able to update references, make a copy of that, and generate a similar but different job in pretty quick order. And I'm just jumping in here in the performance evaluation in SolidWorks to kind of showcase what we're looking at here. There's 1,645 parts, of which around 152 unique part files. It's got some stats on assembly, mappings and things as well. So lastly, I'm going to jump over to the PDM add-in that we've been discussing and showcase how that works. So here, if you take a look, there's all the references downstream, and you can see what you have locally cached. The equals is the latest copy off the server. The red down clock will be an older version. A green up clock will be you have the newest version, right? You can cache prior versions here, check in and out, and then in this case, I can actually release this file right through SolidWorks. Now here it's showing a number of files that are in a different state, right? If those are standardized parts, they should be off in the standard parts workflow. and they're unaffected by the release of this top-level assembly. So they don't necessarily need to get rev bumped as things move forward. Now, assuming that the engineering manager is going to take a look at this next, he can be in SolidWorks with it. He can even have it open live right now, and he can go in, take a look, and then choose to release or bounce that back within the workflow. And then here, it's just pushing through and rev stamping these files again, showcasing what I did in Windows Explorer earlier. So here they all bump a version, they all go to a production release state, and then if you look, Rev A has been stamped on all those files. And like I mentioned earlier, that can also kick out a number of PDF files. We can kick out IGES, Parasolid, Step, and anything else for that matter that SOLIDWORks can do a save as on.
That looked a ton easier than what I have traditionally gone through. I mean, it was a couple buttons. It's all being tracked through. I mean, you released everything all within a couple of minutes. So definitely some good stuff to look at there and think about, moving forward and seeing how that PDM can definitely help us out. You know, kind of concludes what we have here. We did have a couple questions came through that I was able to answer to some of you guys. We also found there was one question that says, could you share the complete AADA large assembly project, which was shown in the presentation? This is one of the things that you actually saw a little sneak preview. We do have some self-guided training, online training that's coming up. We have a bunch of different classes, but that assembly was actually made specifically for that class so that it could be shared out to other people. So definitely, if you want to get access to that, I would say look into that online large assembly presentation training that's coming through. It should be out here within the next couple of weeks. But if anything, you can always hit me up on email. Speaking of which, we do have our emails here. So my email is ryan.cole@goengineer.com, and John is jmacarthur@goengineer.com. And then also, if you're interested in the PDM, and if you don't happen to have it, or maybe you want some changes done to your current PDM system, not sure how to do them, we have the website for our services to be able to talk to John and some of his people there that are out there. So the other thing that came through as a question, John, was there was a tab, and I had seen it as well too, and it said Go Report. What is that all about?
Sure. So, Ryan's been working on that data set for a little bit that he brought up there, and I challenged him to make a really cool assembly that we could use for large assembly classes, right? One of the big challenges that we've run into is there's lots of really cool large data sets out there, but we couldn't share them and use them and put them out for training purposes because they're proprietary data. So I challenged Ryan to make a really cool machine that did something weird, right? And I was pleasantly surprised with, and I don't know if anybody caught it, that's actually a turkey dinner assembly machine. So it's got a gravy bin and then
don't forget the potato dollop.
Potato dollop and everything, and it's got all the equipment that you would use in an automated equipment assembly, but just does an absolutely absurd task just because we could, right? And likewise, we got a chance to build something unique and cool here recently at Go. And I'll jump out and show you this Go Report tab. So PDM has some really, really cool capabilities for engineering change and engineering change documentation. So one of the things that I didn't showcase yet was that you can actually fire, a new EC within the system. And that EC can be a Word or a PowerPoint or an Excel spreadsheet. And that will fire up a form that lets you build an EC and then attach it to files within PDM. So I'll go ahead and fire one here. And then that pulls just the next EC number. I'll attach it to, part number 12345. And then this particular EC form requires a department because the EC form directory is broken down by that department, right? So if I say this is the assembly change and I need to, get an engineering sign off on that, that's all I absolutely need to key in. Now these other bits of information, these can tie directly into Word or Excel and populate that information downstream. But for the showcase of the Go report, I'm just going to go ahead and fire that EC file. It's going to generate a new EC within the system that goes here into this assembly folder, and then you can see that new Excel document here. Now what the Go report tab is doing is this is a specialized software that GoEngineer has recently developed, in fact here in the Midwest, And what we've done is we've leveraged some new functionality over the last couple of years in PDM that allows you to build a custom tab here and pull in custom information. And I'm leveraging a software that's free out there called SQL Report Builder. And we are pulling in information from the SQL database in PDM to populate customized information on your individual vault. So there's 3 different style reports available today, although these are completely customizable for your organization. And I can get a file report, which shows similar information to the data card, but can show me how long a file has been in a workflow. So if I take a look at this, it went through ECR review to pending to completed, and kind of shows the amount of minutes in this case. In a real life environment, that's probably more days, but we've just customized it for demo purposes to that shorter time frame. But I can even go and see folder specific information. So if I go to a project and I choose an individual project, it runs a completely different report and shows me information based on that. So I'll expand up here so you can see a bit more of that. It shows me how many files are in that project and who has them checked out. It'll come over here and show me what workflow states all those files are in. It also has the files listed below and what workflow state they're in below, as well as links to those files within the interface, and you can actually hyperlink and get to the data from there. And all of this information is available in PDM. It's just not presented in this way, right? And likewise with this engineering change report. So really the brainchild, I think, behind Go Report was to really give a lot of information about engineering changes, right? PDM can put them in, and you can search for this information, but a lot of companies live and breathe by their engineering changes. So what we wanted to do was build a specialized utility that when you clicked on a button would give you a full report of the ECs within your system. So here, regardless of what folder I'm clicked on, this is now reporting on my EC workflow with my particular EC state names. So here we can see that I've got an EC per state, and obviously I'm using a smaller data set here that compared to a real life environment. I've got 6 ECs that are incompleted. I've got 1 on hold, 1 in pending, and 1 in review, right? Now that one that I didn't check in yet is still sitting over here in its initial state. So if I go ahead and check this guy in, that'll put it into the system. And then if I jump over and take a look at this EC form, we can see here that I now have 1 in the EC initiated state. So this is live time updating what it reads out of the database at your PDM environment. Now down below here, I'm highlighting effectively bottlenecks within the EC process, right? So what ECs are sitting in review, which ones are in process, i.e. engineering's already working on them, and then how many just went on hold because of whatever reason, right? We took another chart here and broke down the number of ECs per project. So you can see here I added 1, 2, 3, 4, 5, and I now have 1 EC within that. And I've got 6 associated out to project 9999. And this just kind of gives you a breakdown of how many different ECs are in different projects, etc. And then over here, we actually calculate the average time it takes to process an EC. So I had mine set to minutes, and one thing I've kind of learned here is that minutes add up pretty fast as I leave things within my EC environment, right? But what this gauge is meant to be, and we'll set this to days in a production environment, is to showcase you your throughput, right? So you can see what, how fast EC changes are actually occurring. So what we're measuring is how long it takes an EC to get from initiated to completed, right? And then it takes that and shows the last 30, 60, or 90 days of results to give you an average minutes or average days to complete an EC within the process. So we're in our infancy with the new creation of Go Report, but we are in some beta testing now with customers, and as it stands today, just so everybody knows, if you already have a PDM Pro environment, the software to bolt this on is free. It's just a download from the SQL Report Builder, and then we offer services to set this up, and we can make it a user or group specific report capability that shows or does not show that tab to your end users. And really the target market is going to be your engineering administrators, engineering managers in general, anybody really dealing with the throughput and the engineering change process. But if you've got other processes in your PDM involved, this can be completely customized to show you whatever information you'd like to within all of these charts.
And it's pretty easy to customize that too. I mean, it's not like they have to have anything special or implement it in a particular way, correct?
No, we basically dissect, how you set up your PDM, and we've got experts on hand that know what those database calls are, and we have effectively custom programmers that write the scripts. And it's not really custom programming, but it's just kind of more advanced SQL queries,
Okay.
and then you pull those SQL queries to make that capture information very easy to the end user.
Well, cool. All right. And they can contact the service team for any information on this as well.
Yeah, absolutely. It'll probably come over to me since, the Midwest is the one who came up with it, but we're effectively scoping anybody who wants to take a look at what we have now or customizing it to suit your environment as well.
Well, cool. All right. Well, I think that kind of wraps everything up. There was a couple questions that came through. I've been able to answer some of those and stuff like that. And hopefully, if there's any more information, feel free to get a hold of us through email or call the service team. So I do appreciate everybody's time. John, thanks for jumping on and kind of help facilitate this and show some stuff. I think it hopefully it looks from the questions alone looks like it opened some eyes up. So we'll go ahead and call it a day at that point. All right, John.
Sounds good.
All right.
We'll stay on the line for a few more minutes if there are any other questions. And appreciate your time.
All right. Frank Root, I have a question here that says you have PDM and you're still having corruptions. Um, we were talking about some corruptions, John, as far as if they have a PDM system, they're still getting file corruptions. Would that be a support call, you think, to try to get someone online with them?
Yeah, it'd probably be a good idea. Off the top of my head, if you're still seeing file corruption, I definitely want to look at whether or not it's PC specific. If we're talking one user, one PC gets more corruption than others, I'd be suspect of the hard drive. If we're talking lots of different users, then there's something more at play there. You're typically not going to see, a file corruption on a local drive. I don't know the last time I did. So there's definitely, something going on there.
Yeah, he does say it's periodic and it is happening system wide, not just on a particular PC. So I'd almost say, he's asking if it's network related. I would almost say probably get a support person online. They're going to be able to look at your setup, do some testing, check things out, and probably give you a better answer. So I would definitely push you towards that at that point. So thanks, Frank. I appreciate that. Don't have any other questions coming in. We did have a good job, so I'm pretty sure that was directed at me, but hey. Got a couple other questions that came through. Is there a way to force all caps use when creating files or entering data card info?
Unfortunately not, and I know exactly why you're asking that. SolidWorks has added that functionality to some of their tables and things over the last few years, but yeah, I'm not aware of any way to force caps lock on. The other one I see up here is currently running 2018. This was 19 or 20 help with speed, and then there are any new features to help out. Yes, particularly 2020 has some performance enhancements to PDM, as well as some really cool new searching functionality. So on the performance side of 2020, one of the main things that corporate SolidWorks identified that was a performance problem was the PDM add-in, while you had it live open in SolidWorks, was constantly talking to the database for information, and that constant traffic was causing some performance lag. So in 2020, they've found a way to kind of dial back how often it's hitting the DB for that metadata information and things, and that's caused a pretty significant performance gain while working with data inside SolidWorks. There's also been a few service packs over the last couple of years that have addressed copy tree slowdowns, bill of materials showing, and the contains tab as well. There are some things that were kind of double hitting the database there that they got cleaned up as well. And then 2020 brought some really great new searching functionality to the table. So in the past, PDM, you had to effectively run a complete search and then know what you were looking for, and as you searched, it had to be in very specific orders and things. Well, now this quick search lets you just type in, specifically what you're looking for. So if I look in all folders for a bracket, and run a search, it'll come back and find that stuff without having to actually even launch a search bar. And as you can see here, I've got, a number of these, and I've got, motor bracket and DC bracket and things. Well, one thing that's, really slick here now is I can do DC bracket, but you'll notice in my search, it's DC motor bracket is that file, right? And in a typical PDM search, this will not return the value because the string of DC and bracket don't, that never shows up. But now you can add an or and or not statement in the middle, and that will then run a search and find you either or, right? So it's now finding DC or bracket, which comes back with a number of other results, or I can change this out to DC and bracket, and I'm getting that DC motor bracket, and you can even get them out of order. It can be bracket and DC, right? Or I could do, not, right? And now that's going to show me all of the DCs without the word bracket in them. So just really nice searching enhancement for 2020, and for that alone, I recommend upgrading. So question on, for an upgrade from 2019 to 2020, is it mandatory that users check in their files before the upgrade? I would not say the word mandatory, no. It's recommended, and I do believe it is a good idea to have people check in their work, but realistically, if there's a file checked out on a hard drive to a local view, the server gets upgraded. In fact, you can even do a server move, and when the server's been reattached to the local view, it will just check in and continue to work. The one danger that you risk is if anything goes wrong with the local view, if it needs to be recreated, those files can get what I call orphaned. And an orphan file is not lost, but it is no longer really attached to PDM. So you kind of have to copy it out, recreate a local view, and then overwrite to get it back in. But I've not really had a whole lot of problems with local views lately. So while it is my recommendation for all users to check in work, and I think a good practice, I don't stop an upgrade if a user has some files checked out. We still move forward, and I consolidate any problems that happen from there, but it's not a very common problem.
You're going to be quoted on that too, I hope you know.
I'm doing it every day, so.
All right. Well, we are at our hour point. We're going to go ahead and close this out. If there's any further questions, please feel free to get hold of us or support or services to answer your question. We'll be more than happy to help you out. Once again, John, thanks for taking some time to come and talk to me about this stuff today, okay?
Thanks, Ryan. Everybody else, have a great day.
Thanks, guys. Bye-bye.